So this first question here wants us to explain a dynamic equilibrium. They've only given us 1 mark for this. We've got to make sure we get both points across in the answer that we have. And what we need to say here, dynamic equilibrium is the rate of the forward reaction is equal to the rate of the backward reaction. Okay, next one is a equilibrium question, and let's just take a look through it, and I'll go through the answers with you. So first of all, it tells us here that the forward reaction takes heat energy in, and therefore it's endothermic. So what I would do first of all is you write forward reaction, endothermic, and if it's endothermic, that means it's going to make the surroundings feel cooler. Because that's happening that way, then this way is exothermic, and that's going to make the surroundings feel hotter. Other thing to do is write down that there's 1 mole here, and I've got 2 moles on this side. So at the moment, this side has got higher pressure because there are more moles. So what it wants me to do is suggest suitable conditions should use to maximize the yield and production. So I've got to talk about yield, and I've got to talk about the production, the rate of production, which means attainment. So this side is all about attainment, which is rates of reaction. This side here, I'm using Le Chatelier's principle, equilibrium law, to work this out. So let's go through this. First one is looking at temperature in terms of equilibrium. And what I'm going to say here is this reaction favors a higher temperature. And the reason why is because if we increase the temperature, according to Le Chatelier's principle, the reaction will try and lower the temperature. To lower the temperature, if I just come up here again, to lower the temperature, to make it cooler, this reaction is going to come to the right, and therefore the amount of propene is going to increase. So the equilibrium will move to the right, because in the right direction is endothermic, and more propene is going to be produced. If we now look at temperature on the rate of production, if we have a high temperature, then the particles will have more kinetic energy. If they've got more kinetic energy, they will move with greater energy. Therefore, there'll be more chance of successful collisions, and more chance of those collisions having energy greater than the activation energy. This makes the rate of attainment increase as well. Step into the other side, look at pressure. So in this situation, there's 2 moles here and 1 mole here. So if I try and lower the pressure, according to Le Chatelier's, it will try and increase the pressure. To increase the pressure, it's going to move to the side with more moles on, because that's high pressure. It's going to move to the right, which is what I want it to do. So low pressure, equilibrium says it's going to try and increase the pressure. Equilibrium moves to the right because there are more moles on this side of the equation, and it leads to an increase in propene. But if we have a low pressure, then it reduces the attainment, because there'll be fewer particles in a set volume, and therefore there's less chance of successful collisions, and the rate is going to slow down. The final thing to mention is about a catalyst. If we had a catalyst, it doesn't have any effect on equilibrium, but it will increase the rate of attainment because it speeds up both the forward and backward reactions by lowering the activation energy and providing an alternative pathway. Each of these bullet points, I make 24 of them. So if you count up how many points you've hit, and then work out how many marks you've got for that particular question based on the points you have hit. Okay, next little bit is a calculation. Here we go. So, state the maximum volume of propene. Let's get my pen working here. State the maximum volume of propene. So I want to know how much of this I'm going to get that you would get from 300 decimeters cubed of this. Well, if you look at the ratio there is 1 to 1. Therefore, I will get exactly the same 300 decimeters cubed. Okay, in this question, we are going to try and work out the mass of hydrogen that's going to be produced. We're told there's 900 grams of propene. So what I'm going to do first is convert that to moles. If I want to work out the moles, it's going to be the volume divided by 24. So the moles of the propane is volume divided by 24, which is 900 divided by 24. Let me just work that out for us. So I've got 900 divided by 24 is 37.5 moles. Okay. Next, we want to therefore know how many moles of hydrogen we've got. So if you look at the equation, the ratio I've got there is 1:1. So that means the moles of H2 also equals 37.5. So all I need to do now, let's draw a little wobbly line down there, is work out the mass of hydrogen. To work out the mass of hydrogen, we're going to do, if I write my over triangle here, so it's Mr. Moles is underneath the mass. So I want to work out the mass. The mass, therefore, is going to be the MR times by the moles. The MR for hydrogen, well, hydrogen's got a mass of 1, but there's H2. So the mass of hydrogen is 2. Times it by the number of moles, which is 37.5. So I've got times by 2, and that's going to give me 75 as an answer. But that 75 needs converting because that's going to be in grams. So let's convert that into, because it wants the answer in kilograms. So all I have to do there is 75 divided by 1,000, 75 divided by 1,000, and that's going to be 0.075 kilograms. Marks wise for that one, there's 4 marks in there. So you're going to get a mark for that little bit there. You can get a mark in here for then the ratio, a mark in here for that, and then a mark for converting that to the right units.